Hi, this is Merlin. Today we're going to talk about the garbage collector part 3. It's also known as like Jankbusters part 3 or the Orinoco garbage collector. Our first video we focus on the why Jank is working, and second video we talk about the implementation of garbage collector, and we talk about the Orinoco also. And this video we're gonna go deep about the how it works, how a garbage collector it works, and I'm gonna talk about the Orinoco also, but it's kind of different than the last video. So first, I'm gonna talk about the introduction of garbage collector. Second, I'm gonna talk about the major GC, what is major GC, and third, I'm gonna talk about the general layout. Fourth, I'm gonna talk about the minor GC and terminology for Orinoco. So, so garbage collector has to do some few essential tasks, which are identify live or dead objects and recycle reuse it, the memory occupied by dead objects, and compact and defragment memory. And this is kind of optional because compact compact or defragment memory is kind of costs a lot, so these are kind of optional. So the straightforward approach is to pause JavaScript execution and perform each of these tasks in sequence of on demands, right? And this will also cause the junk, right? We talk about this thing in the like first video of garbage collector. So there are two types of GC. The one is major GC and minor GC. So what is major GC? Major GC is also called as for mark compact. The major GC collects the garbage from the entire heap. So the big difference between the major GC and minor GC is major GC collects the garbage from the entire heap. So the range is entire heap, but the minor GC um, collects the garbage in the only in the young generation. I'm gonna talk about why there's like two of it and why there is some such such uh, minor GC and why it focuses on the young generation. I'm gonna talk about it later. So major GC happens in the three phases: marking, sweeping, and compacting. So marking. So what is marking? Marking is like we talk about this a lot. Marking is it collects reachability as a proxy for liveness. So it's just trying to mark if it's reachable. So if it's marked, it is that they call us live. If it is unmarked, it's gonna be like garbage collected. There's a GIF for it. I'm gonna show you um, this one. There's a mark and if there's like no mark, it's called sweep, and it collects the dead objects. But in V8, the sweep is kind of different, but it's also collecting a dead objects, but it's rather um, it's kind of more improved version of it. So in here, sweeping is process where gaps in memory left by dead objects are added to the data structure's core free list. So, so once the marking complete, the GC finds the contiguous gaps left by unreachable objects. So, example, if it is like gap that caused by dead objects, so it added to the free list, and if there's like future objects, it compares the memory space. But if it is like same memory space on the future object, it put it here rather than creating a new page. So compaction, we talk about it also. This we copy a surviving object into other pages. So not currently being compacted. So one potential weakness of a copy collector is the copy's surviving object is kind of high cost. We pay high cost. So compaction is only some highly fragmented pages, not all little bits fragment pages. So I told you this kind of optional. So let's dive into more. So there's a lot of words. I'm gonna read it by you, just a little. So major GC in VA start with the concurrent marking. So as the heap approaches dynamically compared limits, the concurrent marking task are started. So which means that if there's like a lot of objects and if the heap limits it did hit over the heap limits, there's like GC and it's called concurrent marking task started. So it's like if there's a JavaScript here, so there's a hyperthread, main thread hyperthread. So this part, even the JavaScript work is running, the marking is going on. So the garbage collector knows which is not marked or not. But the to make sure it finalize marking, finalize marking, and if there's like still that object, it starts sweeping task on in here. So it blocked the main thread, so that it cause like if it takes so long, you could call of course it's called a junk. So concurrent marking happens entirely in the background, concurrent marking here, this part, while JavaScript executing in the main thread. And there's a hyperthread sweeping, and major GC uses concurrent marking and sweeping, and power compaction and pointer update. Compaction and pointer update. So when concurrent marking finishes, we reach the dynamic allocation limit, and the main thread performs quick. Yeah, I talked about this marking finalization step, and began main thread began pause, and it scans roots again. That's called finalization marking, and then along with it, the number of helpers start to power compaction and pointer updates on here. So yeah, I talked about this because marking after marking, the sweeping if the sweeping begins, that means some kind of dead objects, and there's gonna be like defragmentation, and this is kind of optional. And if it's need to compact, so it uses per thread to enable the time reduction of the GC, so it compacts and point updates it in the same time. And next is generation layout. So generation layout, we're gonna talk about the ages thing in 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 young generation or generation or the entire heap. I didn't talk about this in last video because there's no such a thing about generation layout at that blog. But this is kind of latest version because it released on the 2019, so that's kind of the little bit latest version. But even though it is still old because we are in the 2023. So there's a young generation or generation, and it's split for the two nursery, intermediate, and old generation. So example nursery. So nursery is the new objects are 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 first allocated. I mean, like the meaning of the nursery is kind of this one, right? So these babies are new objects. So intermediate is like when you survive from the GC, it go, so the age is called intermediate. If it is alive in after one GC again, it's gonna be called this old generation. So there is a general hypothesis, and that is why minor GC came. So basically, state that most objects die young. So in other words, most objects are allocated and then almost immediately become unreachable perspective of the GC. So so that is also why we try to focus on the young generation and why we focus on the live object. General hypothesis states that most objects die young. Yeah, sure about that. Pretty sure this is not only about the JavaScript language. It's kind of valid in all dynamical language. So the young generation, right? Young generations The reason we focus on the lib because general, general hypothesis that most objects die young. So focus on the live object. That means like other than that, beside that, other objects are implicitly dead objects. So that is why we focus on this kind of stuff. So next is minor GC. So minor GC also called a scavenger, collect garbage in the young generation. So think about a raccoon. Raccoon scavenge is also called clean or collect the garbage. It scavenges the trash, right? It doesn't like old trash, old rotten trash. It like fresh new trash, right? Yeah, and this raccoon also called the scavenger, one who cleans the street or the trash. So V8 uses semi-space design. We talk about it, and V8 memory visualization. And half total is always empty. Although for this evacuation step is like after survival from GC, the objects are moved to the two space or some kind of the old generation space, right? So in mine GC in scavenger, there's like marking and evacuating and pointer updates. I can talk about this. So here's a nursery intermediate. So nursery is like the ages, right? So where the babies come in, where the fresh or first objects, new objects are stored in the nursery, and the labor change. This is kind of same thing, but the labor changed. The reason we use nursery intermediate is to show the ages. So first space and two space, and if it's still alive from the one GC, the lead object go here to space and this called the evacuation and they put mark on it. The reason they put mark on it is because to identify this object is alive from the one GC because after more GC this mark the object has this mark go to our generation. So we have the pointer updates and after that we switch it and this also called as nursery and if there's gonna be more objects and if there's GC again, this stuff goes to the old generation. And the reason why we don't use this permanently, just only by like only for first time, not first time, it doesn't use it often online because we talk about this. The half of total space is always empty, although for the evacuation step. So that is why we have to switch kind of thing. And after we go to the originator zone, of course, pointer updates had to be enabled. I don't have image on it, so skip it. So let's dive into more about scavenger or minor GC. The scavenging task had to synchronize via atomic read, write, compare, and swap operation when they try to evacuate. So that means like when they try to evacuate, they have to put like do the atomic read, write, compare, and swap operation at the same time. And below image is Paris scavenging. So what is atomic read, compare, and those kind of stuff? Atomic means like the operation that run completely independent, completely in the sorry, independently of any other operations, and you cannot stop it. So which means that the synchronization is happening, right? So this is independent. So it is independent. So that means like there's no conflict. You understand? If it's like dependent, there should be dependencies on it. So there should be like big problem because some operation can trigger the other operation. But if it's atomic, it doesn't triggers. There's no dependencies between those things. So we can make sure synchronize happen rather like with no confusion, with no like attack on it. A read and write, automated read and write ensures that data is fully read or fully written in one go without the risk of another thread reading right through it midway. That's what I'm trying to talk about. So what is compare and swap? So we talk about compare swap, right? Compare swap is compares the current value of a memory location and given value. So if the current value is equal to the given value, it modifies a memory location and new specified value. Yeah, this is kind of same thing. So if it's GC and if it is and this have to be moved, right? So we have to check if it's like it is like same, it is like same here, and that's course it compare and swap. So that's synchronized multi-thread. So that one is like I added two more, so it leaves for the pointer so the other worker which reach object can update other objects as they find them. For fast synchronization, free allocation of surviving object, the scavenging task use thread local allocation buffers. So what is thread allocation buffer? So thread local means that the select data or resource to a resource is local to a specific thread, but not shared among other threads. This is kind of also independent thing. And allocation buffer is reserved space in memory where the object can be allocated. So sorry, local allocation buffer (TLAB) means that the reserved space in memory where specific thread can allocate object without interfering other thread. So the reason why I put here because we do parallel thing, so we have to make sure that um, there's no there's no interface between the thread. So last is terminology. It's not last. It's kind of last. So it's kind of terminology for Orinoco is 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 the before the how it really works or the reality of Orinoco. And there are parallel, incremental, and concurrent, and the goal is to free the main thread. The parallel is easier and concurrent is harder, and increment is like the middle size of it. And easier, harder. There's are pros and cons. Harder means like the garbage collector is effective and it decreases the size, not size. It decreases the time of the GC stopping the main thread. Power is like opposite. The incremental is like the middle of it. So what is power GC? Power is probably easiest way. I told you about that to move some work of the main thread. So where your main thread and your helper threads do some work at the same time. So there's like GC on it, but it is still stop the word, which means like is there's a still main thread pause. It could reduce the time, automate pause by factor n, and a main thread and a helper thread works on the same time and same thing. So concurrent GC is the hardest one, right? Concurrent is when main thread executes JavaScript constantly and helper threads do GC work totally at the background. Yep, it does do at the background, right? So this is difficult because anything in the JavaScript can change. Example, the JavaScript execution is like going here, but somehow if the garbage collector change something, so heap could change because of the change of the heap, the JavaScript execution could be like go some weird that we don't want. So so to block this issue, we have to make sure that it doesn't affect on the main thread, but that is very difficult. So the advantage is of course is the decrease size, not decrease size, decrease the the time of the GC, and also the totally free SQ JavaScript. And because if there's like block on it, stop the word event, there's a jump on it, and that could directly affect the user experience. And you don't want that. Your boss don't want that. So GC happens entering the background, and main thread is free to run JavaScript. So what is reality? So reality is we use power scavenging, and it was introduced on 2019. Before is like this kind of thing, but after they use power scavenging, so it we can use up to 7 hyper thread. I don't know right now in the 2023. So main thread and 7 hyper thread will split the work into eight parts. So the most difficult is 3 second techniques because anything on the JavaScript ship can change anytime. So we kick all these threads at the same time and we do application marking. So in the scavenging, we actually interleave these phases, and at the same time, we do marking, evacuating, and pointer updating at the same time. So that means that goes through independent. That doesn't affect the others' evacuation and pointer updates. So either time GC. So this is kind of easy. Example, I'm gonna explain this really fast. Example, uh, you render the animation work faster than what your Chrome expected. So example, your animation work like stop it here rather than this part, and your IDGC came in, so it does do like like garbage collecting stuff, but at this pair time. So spare time is like before this event happens, and that's called ID time GC. Thanks. Oh, this is last video of VA garbage collector. The reason there's so many sorry, test text on it, because this stuff was really hard, and I recommend you just read the V8 blog on it. And but still, it is worth it. And and you knew that everything is related. Of course, operating system, memory management. Of course, the CS information is very important, and the V8 memory visualization help us to think about the layout of the heap, right? So everything is related. Okay, bye bye.